Hey, welcome back. Now let's start implementing the UART initialization, which we have to carry out in order to use the UART peripheral in this project. Now, for that, all those initialization we are going to do in setup hardware. So what are the steps involved in using the UART peripheral? Now, the first one is enable the UART peripheral clock. But before using UART peripheral clock, so let's find out which UART we are going to use in this project. So that is very important because microcontroller has various UART peripherals. If you open the data sheet of the microcontroller, so here I have opened the data sheet. It has UART 1, UART 2, UART 3. That is actually collectively called as UART, Universal Synchronous Asynchronous Receiver Transmitter Module of the microcontroller. And we use that module in asynchronous mode. We do asynchronous communication, so that's why we call it as UART. So it has various UART modules, UART 2, 3 up to 6, and in this project let's use UART 2. That's because in my Nucleo board, when I connect my Nucleo board to the PC, so here you can see that in the device manager, in the ports section, the Nucleo board actually enumerates as a virtual COM port. So my computer communicates with the STM32 Nucleo board over this virtual COM interface. And this virtual COM interface is actually enumerated by the firmware which is present on the ST-Link circuitry of the Nucleo board. This virtual COM interface works via the UART 2 peripheral of the microcontroller of my Nucleo board. So if you want to know more about that, you have to go and check the user manual to see which UART peripheral is used in order to enumerate as virtual COM port in the computer. Now that information you can get from the user manual of your Nucleo board or Discovery board or whatever the board you have. If it supports virtual COM in enumeration, then they will also mention which UART peripheral is used for that purpose. So if you go to the user manual and if you go to the section 6 here, section 6 hardware layout and configuration, and there you will find UART communications. So just click over that. And in this section, UART 2 communication, it says that the UART 2 peripheral is used for virtual COM purpose. So here you can see that by default, the UART 2 communication between the target STM32 and ST-Link MCU is enabled in order to support the virtual COM port for mbed. This selection of peripheral may not be true in other boards. For example, in Discovery, the virtual COM support is not actually available. So you have to arrange or you have to buy one extra USB to UART converter dongle in order to achieve the virtual COM communication between the PC and the board if you are using Discovery board. So you have to check your board whether the virtual COM support is available on your board or not. From Nucleo it is available, no problem. So even if it is available, check which peripheral is used, whether UART 2 is used, UART 3 is used. So you have to check that by going to the reference manual. And if it is Discovery, then you probably have to buy one USB to UART converter hardware and then you have to use that. So I have attached a document with this lecture how to use external USB to UART converter hardware in order to communicate with the board via PC. So now let's move forward with our code. So enable the UART 2 peripheral clock because we are using UART 2 peripheral. Now all the clock management code is, as I said, it is actually written in the rcc.c, isn't it? So let's go to the rcc.c. Alright, so here I am in the rcc.c and here there are various APIs in order to handle the clocks. So you can see that rccahb1 peripheral clock command, rccapb1 peripheral clock command, rccahb3 peripheral clock command, etc. So don't get confused by all these APIs. Now the concept is very simple. Just check where exactly the UART UART2 peripheral is hanging. So it is hanging on APB1 bus, isn't it? So that's why we have to use RCC APB1 peripheral clock command. So let's use that. So let's go to the main.c and type RCC underscore control space and APB1, right? Peripheral clock command. Let's use that. Fine. Now let's go and explore this API. So what it says enables or disables APB1 peripheral clock. Great. So it says enables or disables the low speed APB, that is APB1 peripheral clock. It takes two arguments. So in the new state, you have to mention whether you want to enable the clock or disable the clock. We have to use enable. To whom? So for that, you have to use the first argument. Now here it is. All these are the peripherals who are actually hanging on APB1 bus. So here it is, UART2. So let's use UART2 and then enable. So that will enable the clock. So let's use this. Now let me go back to the main.c and here RCC APB1 underscore UART. What is that? So this one, let me just copy this and let me just paste here and enable, right? So I did a mistake here. This is actually UART2, sorry. Alright, so now the UART communication happens over two pins, isn't it? Now one is called UART TX and another one is called UART RX, isn't it? Because UART is actually full duplex communication where data is transferred over the TX line and the data is received over the RX line, isn't it? So we have selected our UART peripheral, that is UART2, but on what pins of the microcontroller the UART TX happens and UART RX happens? So that we have to find out. So at the end of the day, the data communication should happen over the microcontroller pins, isn't it? So these details you can get from multiple sources like pin description table, from the data sheet, or from the user manual of the board. Now, if you check the user manual of the board, so here it clearly says that the UART2 communicates over the PA2 and PA3 pins of the STM32 microcontroller. So PA2 means GPIO port A pin number 2 and PA3 means GPIO A pin number 3. So which one is RX and which one is TX, you have to find out that. But the UART2 peripheral of the Nucleo board communicates with the PC over PA2 and PA3 pins of the microcontroller. Now, in order to find out who is TX and who is RX here, so I would suggest you to go and check the data sheet. Now let's go to the data sheet, and in the data sheet there is something called pin description table. Alright, so let me show that to you. So here, pinout. So here you can see that pin description. Alright, and in the pinout and pin description, go and check the alternate function. And here just search for PA2. Here it is, PA2. And here you can see that PA2 actually acts as UART TX when PA2 is kept under the alternate function mode 7. So there are alternate function modes available to pins of the microcontroller. So more on that we'll discuss as we make a progress. But here you can see that PA2 has the capacity to act as UART2 TX when configured in alternate function mode 7. And PA3 acts as UART2 RX when it is configured in alternate function mode 7. So that also means that PA2 can act as timer 2's channel 3 when you configure PA2 in alternate function 1 mode. Great. So that means PA2 is TX and PA3 is RX. Now let's note down that information. Alright, PA2 is UART2 TX and PA3 is UART2 RX. So that means now the second step is we have to configure the GPIO port A pin number 2 to behave as UART2 TX and GPIO port A pin number 3 to behave as UART2 RX. Now let's do that. So that step we call as pin alternate function configuration. Let's do that. Alternate function configuration of MCU pins to behave as UART to TX and RX. So now for this we have to use the GPIO driver. Now let's go to the GPIO driver to explore that.